Welcome to How the Browser Actually Renders a Web Page, an autism-friendly coding tutorial where we'll calmly walk through what really happens when a browser loads a website. By the end of this video, you'll understand how browsers turn HTML, CSS, and JavaScript into the actual pages you see on your screen. We'll break this into 8 clear steps, and along the way, you'll see how browsers build the DOM, calculate layout, paint pixels, and render the final page. Let's start with step 1, requesting the page. When you type a website address into your browser and press enter, the browser begins a long chain of events. First, it needs to figure out where the website actually lives. To do that, it performs a DNS lookup. DNS stands for Domain Name System. You can think of DNS like the Internet's phone book. It translates a domain name like example.com into an IP address the browser can connect to. Once the browser knows the server's address, it establishes a connection and sends an HTTP request asking for the web page. Pause this video here if you need more time with this step. The server responds by sending HTML back to the browser. And something important happens here. The browser does not wait for the entire page to finish downloading before it starts working. Instead, the browser begins reading and interpreting the HTML immediately as it arrives. This process is called parsing. That means rendering can begin before the full document is finished downloading. Even with just this step, the browser is already preparing to build the page. As the browser parses the HTML, it converts the document into something called the DOM. DOM stands for Document Object Model. The browser reads the HTML from top to bottom and turns each element into an object called a node. So a paragraph becomes a node. A button becomes a node. A div becomes a node. These nodes are connected together into a tree structure called the DOM tree. The DOM represents the structure and content of the web page. JavaScript can later use this structure to interact with the page. See, even with just HTML, the browser now has a structured representation of the document. Next, the browser processes CSS. CSS is parsed separately from the HTML. The browser converts CSS rules into another structure called the CSSOM. That stands for CSS Object Model. The CSSOM contains all the styling information for the page. And here's an important realization. The browser cannot fully render the page until both the DOM and the CSSOM exist. Why? Because the browser needs both structure and styling before it knows what the final page should look like. That's why certain CSS files can delay rendering. Pause here if you want a moment to process the difference between the DOM and CSSOM. Now the browser combines the DOM and CSSOM into something called the render tree. The render tree contains only the elements that will actually appear on the screen. For example, elements with display none are excluded. This is important. The DOM contains all elements, but the render tree contains only visible elements along with their computed styles. At this point, the browser finally knows what needs to appear on screen and how it should look. Next comes layout, sometimes called Reflow. This is where the browser calculates the size and position of every visible element. You can think of this like arranging furniture inside a room. The browser figures out where things go, how large they are, and how they affect surrounding elements. This process can become computationally expensive on large or complex pages. And certain JavaScript operations can force the browser to recalculate layout repeatedly. That's one reason some websites feel slow. After layout comes paint. This is where the browser actually draws visible pixels to the screen. Text appears. Colors appear. Borders, shadows, and images are painted. This is the first time the web page starts looking recognizable to the user. Complex visual effects can increase painting cost. That's why excessive shadows, filters, and large visual effects can sometimes reduce performance. Now the browser is very close to displaying the final page. The final rendering step is compositing. The browser combines different painted layers together into the final image you see on screen. Modern browsers often use the GPU to help with this process. This is especially useful for animations and transforms. For example, moving an element with transform can sometimes avoid expensive layout recalculations. That's one reason certain animation techniques perform much better than others. At this point, the page is fully rendered. Now that you understand the rendering pipeline, slow websites start making a lot more sense. Large JavaScript bundles can delay rendering. Render blocking CSS can prevent the browser from displaying content. Frequent layout recalculations can create jank. And heavy visual effects can increase paint cost. The browser is constantly balancing correctness, speed, and visual updates. And now you have a mental model for understanding what it's actually doing. So far, we've followed the entire rendering pipeline. The browser requested the page. It parsed HTML into the DOM. It parsed CSS into the CSSOM. It combined the DOM and the CSSOM into the render tree. Then it calculated layout, painted pixels, and composited the final page. This entire process happens incredibly quickly, often in fractions of a second. But understanding it deeply makes debugging and optimization much easier. Now when a web page loads, or loads slowly, you have a much stronger understanding of what the browser is actually doing behind the scenes. And that's a huge step towards becoming a stronger developer. If this kind of direct autism-friendly tutorial is helpful, subscribing is a great way to find your way back here. Thank you for watching, and let's keep learning and growing together. If you'd like to support the channel further, I also have learning resources and products available on my Patreon. That currently includes coding affirmations and the AutistiCoder reference guide, designed to support your learning journey. You can find everything at patreon.com/AutistiCoder. Thank you for your support.